My name is Rajesh Davè, and I am Distinguished Professor of Chemical Engineering Department at NJIT. I was actually a professor in Department of Mechanical Engineering. One of my colleagues who had learned about where they could put nanoparticles on the surface of tiny microparticles, I was very fascinated. And then I kind of realized that this is my calling. Most of the recent work is driven by pharmaceutical, and that kind of brings a different passion, that we realize that the cost and availability of drugs is a major factor. So we decided to focus on how we can improve drug product quality. Most of the new molecules that pharmaceutical companies are coming up with, they are like brick dust or steel chips. They just do not dissolve in water. When you take it orally, it needs to dissolve in the stomach or intestine. So one of the ways is to make finer and finer particles. Our research in principle is all about engineering particulate materials. Size range all the way from nano down to 10, 20 nanometers to 200 or 300 microns. So many drugs actually degrade in the stomach's acidic environment. Essentially, you are trying to put these coating layers in such a way that you are shielding the particle from all types of conditions, whether external to the body or within the body itself. Coating of particles is nothing new. What is unique and innovative about our work is that people have not been able to coat finer particles. Typically anything below 100 micron and preferably below 50 micron. Where we have pushed the boundary is come up with a simple process, eliminated use of organic solvents, complicated process steps, and come up with coating of individual particles. So one of the most innovative coating process we have is probably one of the simplest. So we have this process where a jar shakes at 100 G force. So these high G forces create a lot of collisions between the particles. So the powder isn't like a powder anymore. It is a mass of kind of molecules of gas hitting each other. And as they hit, the smaller particles arrange around the core particle. To make these things even better, we combine two different sizes. Now, as they are bouncing around, the larger particle is not only hitting the smaller particle, but it is imparting higher velocity. Almost like we've created this system of tiny hammers hitting on the surface of each particle, coating with multi-particulate structure is created. We realize that simple coating of one single material doesn't always help. The analogy is like a sieve. You have put a layer so that openings change, releasing drugs at different rates. Thin strip films is an emerging technology. FDA is funding NJIT to develop the regulatory science for strip film products. What we have done is develop this technology that we can put very, very fine nano-sized particles uniformly distributed in a film so that we can reduce the required amount of dosage and so that it does not come out in excretion, which actually contaminate our groundwater and environment. Long term, we could probably visualize that this may help us in implants and patches, and where you want to put medication for 3 months. Even President Obama talks about precision medicine. So we are hoping that all the technology and the platforms which we are creating, you will start seeing more and more things that either dissolve in the mouth, or they can be put as a buccal delivery, or they could be a patch. Over the next 5 years, the best thing that can happen is we actually put our coating into a real commercial product. So every time somebody buys that product, you will know that this is NJIT work. A little bit longer term, we believe that we would have been working with doctors and clinicians under funding from NIH to develop actual strip film based drug that can be given to patients for clinical trial. While there is a biotech revolution going on, this is the manufacturing revolution that NJIT is part of. We want to change the way things are manufactured. It all comes down to making drugs available at reduced cost and higher quality.